everyone. So let us discuss this example. So in this example, we have to find partial derivatives of f with respect to x, with respect to y, and with respect to z. Okay, they have given one point, any general point they have given, that is a1, a2, a3. At this point, a is equal to this one. So at this point, we have to find partial derivatives. So let us start with dA by f by dA by x. So simply I will mention by definition. Okay, so by definition, dA by f by dA by x, partial derivative of f with respect to x at point A. So definition says this is equal to limit h tends to 0 f of a1 plus h a2 a3 minus f of a1 a2 a3 divided by h. So we are finding with respect to x, that means with respect to first component. So that's why I'm adding h only in first component. Okay, so let us use the definition of f. Limit h tends to 0 f of a1 plus h a2 comma a3. So we have this definition of f. Let us use it. What is x here? A1 plus h. What is y here? A2. And what is z here? A3. So let us use this definition. So this says this is nothing but log. We have to simply add these three components. So that means a1 plus h plus a2 plus a3 minus. Same definition of f we have to use to find its value. So it will be log, simply we have to add them, that is a1 plus a2 plus a3 divided by h. I will repeat here. Definition says whatever the components you have, okay, what you have to do, simply log of, inside a log you have to add all those components. So I am doing the same. Log of, I have added all these components, minus log of, here also I have added all these components. Okay, so there is one property of log. I hope all of you are familiar with this property. Log a minus log b is equal to log a upon b. So I can use this property here, since same situation we have log of first bracket minus log of second bracket. So we can divide. So this is equal to limit h tends to 0. So this 1 by h I am writing here. This 1 by h I am writing here. Log of, by property of this log, okay, what can we write? Log a minus log b is equal to log of this bracket upon this bracket. That means a1 plus h plus a2 plus 3, that means a2 plus a3, that means a1 plus a2 plus a3 plus h. Same thing we have, divided by a1 plus a2 plus a3. Okay, I've used this property. I will remove it now, since we want space to write, and that's why. So this is equal to limit h tends to 0 1 by h. See what I'm going to do, I'm going to divide separately. What will happen if I divide separately? a1 plus a2 plus a3, okay, this three terms upon denominator, a1 plus a2 plus a3, plus only last term upon denominator, a1 plus a2 plus a3. Okay, so this is equal to, I will write it here, okay, that thing, yes, I will use this space to write. So this is equal to limit h tends to 0 1 by h log of, see what will happen if you divide, numerator and denominator are same, so they will get cancelled to each other. So we will have 1 only there, 1 plus h upon a1 plus a2 plus a3. So this thing we have. Okay, see, do you know this property of log? N log a is equal to log a raised to n. That means if you have any term as a multiple of log, you can write as a power of a. So same thing we have, getting here n we have, but in this example we have 1 by h. This bracket is nothing but a. So that's why by this property what can I write? Log of this bracket raised to 1 by h, by this property. See, this is equal to limit h tends to 0 log 1 plus h upon a1 plus a2 plus a3. This 1 by h will be the power of this bracket, just like this. So n is equal to 1 by h here, that's why I could write in this way. Okay, so let me remove this property. Okay, so now what is my target? My target is to take reciprocal of this bracket as a power of this bracket. Okay, so let us adjust its reciprocal. So this is equal to limit h tends to 0 log 1 plus h a1 plus a2 plus a3 h. Here we have a1 plus a2 plus a3. Okay, just a minute, more space is required, so I will write just properly to adjust the space. So this is equal to limit h tends to 0 log 1 plus h a1 plus a2 plus a3. Okay, h we have here, raised to here a1 plus a2 plus a3 divided by h into 1 upon a1 plus a2 plus a3. I hope all of you understood. Whatever the I have in a race, in a power, I have multiplied and divided by this bracket. So what happened? We got its reciprocal as a power of this bracket. So this is nothing but, see, this is nothing but limit h tends to 0 log c 1 plus h upon a1 plus a2 plus a3 raised to a1 plus a2 plus a3 divided by h whole raised to 1 upon a1 plus a2 plus a3. Okay, so you can make a screenshot of it, and after that we will go further. So let us continue. See what I'm doing it actually. The logic behind it, limits x tends to 0, 1 plus x raised to 1 by x is equal to e. So this is a one result of limit we have. Okay, so x, its reciprocal should be at power of this bracket, then we can write its value z. So same thing is happening here. Okay, don't consider log first, just focus on this bracket. 1 plus, same thing we have 1 plus. Okay, this term, its reciprocal should be at the power of this bracket. So same thing we have, no? So we can write its value is e. Okay, so that's why we adjust all these things. And the second thing, that result is, we in our school, okay, we have already studied a raised to n plus m is equal to a raised to n raised to m. Okay, we can write in this way, a raised to n into m is equal to a raised to n raised to m. So same thing I wrote here. Okay, so a, this bracket is a raised to, so this n into m is equal to a raised to n raised to m. Okay, so this, by this result I could write it. Okay, so let us continue. Remove it now. So see, this thing I am going to use. Tell me what will you have. So no need to think about this log. Log will come outside and limit will go inside a log, and you can operate. So its value will be log will be outside. Getting na? So if you operate limit on this bracket, see this bracket 1 plus x raised to 1 by x. So its value is e. So value of this square bracket is e if you apply the limit, and raised to 1 upon a1 plus a2 plus a3. Because of this result, I could write the value of this square bracket is e only. Understood? Okay. See, this is equal to, what will happen? We have one more result. Let me write here. That result is, already I have told you, log a raised to n is equal to log n log a. This is a property of log. So can I apply this property here? Yeah, obviously. Log a, at a place of a we have e raised to n. So what will happen, that power will come outside. Okay, power will come in front of this log. So if I apply this result here, we have 1 upon, this is my n now, 1 upon a1 plus a2 plus a3 log e. Okay, so let me remove this property since we have used it now. What is value of log e? Do you know? Its value is 1. So that's why this is equal to 1 upon a1 plus a2 plus a3. Its value is 1. So into 1, that means we will have same. So I will Okay, I will not write it here. So this is deba f by deba x at point A. So this value we have got. Okay, similarly, I will say similarly, okay, actually we supposed to prove it, but I will leave this task to you. Okay, so its value is again 1 upon a1 plus a2 plus a3, and deba f by deba z at point A is again 1 upon a1 plus a2 plus a3. Okay, see, you can make a screenshot of it, and after that we will stop. Thank you, bye bye.